Assalamu alaikum everyone. So in this video we are officially starting A2 trigonometry. So before starting formally, let's just quickly go through the stuff we studied in AS. So first and foremost, the meaning of trigonometry itself. Tri means, let me use a different color. Tri means three, gon means angle, angles, and ometry refers to geometrical properties. Geometrical properties. All right. Trigonometry refers to metry refers to geometrical properties, geometrical properties applied to three-sided figures. And what are those three-sided figures? They are triangles. So this is basically what trigonometry is. All right. Now, as far as the triangles are concerned, triangles are concerned, we have two kinds of triangles. Two kinds or two types, call it whatever you want. We have right angle triangles and we have non-right angle triangles. Non-right angled triangles. All right. In the non-right angle triangles, we are concerned with sine rule, cosine rule, and area of non-right angle triangles. Area of non-right angled triangles. Really sorry if my writing seems a bit messy, but yeah, it's understandable. All right, so this is what triangles are. Now let's look at these right angle triangles. So what does a right angle triangle look like? It is as simple as this. All right, this, let's say this angle is theta. So the opposite one is perpendicular or simply opposite. And this side is called hypotenuse. And this side is called base slash adjacent. So it really depends where this theta angle is. If this theta angle is, let's say, here, if theta is here, then this would be opposite. All right, and this would be the base or adjacent. And but the hypotenuse which will remain same at all times. Understood? So in AS, we all also studied basic trigonometric identities. So basic trigonometric identities, or more simply, basic trigonometric functions, apply to these right angle triangle only. Understood? Now let's just revise them. I will open a new page. You want to remember that basic trigonometric functions only apply to right angle triangle. So basic trigonometric functions. We studied sine theta is equal to opposite upon hypotenuse, or perpendicular upon hypotenuse. All right. And cos theta is equal to adjacent upon hypotenuse, or base upon hypotenuse. And tan theta, right? Tan theta is equal to opposite upon adjacent, or perpendicular upon base. Sorry for that. So, like we studied, you can remember this as so ka toa, so ka ka toa. All right. Sine opposite upon hypotenuse, cos adjacent upon hypotenuse, tan theta is equal to opposite upon adjacent. This is simply a way of remembering it, or if you're comfortable with some other name or some other acronym, that's perfectly okay. You just need to remember it. All right. So now there are some advanced trigonometric functions that are new in A2, that are A2 specific. And if you have studied add maths in O levels, you might as well know them. So let's just move on to them. All right. Advanced trigonometric functions. First, we have cosec theta, which is equal to 1 upon sine theta. In terms of right angle triangle, you can also call it hypotenuse upon perpendicular. All right. We have sec theta, which is 1 upon cos theta. And by the way, you need to remember them, all right? Which is hypotenuse upon base. And then we have cot theta, which is 1 upon tan theta, which is the same thing as base upon perpendicular. And we also have tan theta, which is sine theta upon cos theta. And for cot theta, we also have cot theta is equal to cos theta over sine theta. So sometimes when solving trigonometric identities, you might as well be confused whether this one is applying or this one. So you need to check both, all right, in order to prove the identities. And these are some advanced trigonometric functions. So as to where they would be applied, let me just write it here. They are used in trigonometric graphs, trigonometric graphs. They are used in trigonometric identities, like I just said. Trigonometric identities. And they are also used in trigonometric equations, which must not be a surprise. Trigonometric equations. All right. So, ADMAX students must have studied this this, this, and this. All right, and this you must be remembering from AS. So these 1, 2, 3, 4 are new to you, and you have no other option but to learn them by heart. And trust me, these identities are nothing. The identities we are going to study in future classes are much more intimidating. All right. So now let's just uh, revise the steps to solve trigonometric functions with angles in degrees and in radians. Even though we have studied it in AS, let's just quickly go through it. All right. Steps to solve steps to solve trigonometric trigonometric functions with angles in degrees. With angles in degrees. Step number 1, check the range. You have to check the range. Step number 2, alter the range if necessary. Alter the range if necessary. Step number 3, find the basic angle. Find the basic angle in degrees. And step number 4, apply ASTC. Apply ASTC and check the quadrants and check the quadrants in which answers must lie. In which answers must lie. All right. And step number 5. Step number 5. Apply the following rules. Apply the following rules. First quadrant, if the answer lies in first quadrant. And by the way, just a quick revision. This is ASTC. Then this is first quadrant, second quadrant, third quadrant, and fourth quadrant. In this first quadrant, all angles are positive. In second quadrant, only sine is positive. In third quadrant, only tan is positive. And in fourth quadrant, only cos is positive. Only in first quadrant, all of them are positive. All right, so let me just erase it because it's distracting. Yeah, so in first quadrant, the answer is theta. And second quadrant, the answer is 90 minus theta. And in third quadrant, answer is 180 plus theta. And in the fourth quadrant, the answer is 360 minus theta. All of this is pretty much self-explanatory, but yeah, I'm making you write down each and everything. So these are the rules to solve trigonometric functions with angles in degrees. All right. Also, let's just quickly go through, compare degrees and radians. so that everything is crystal clear. And by the way, if you're confused in these steps, don't worry because we are going to be practicing a couple of questions. So it would hopefully clear everything. All right, so angles. Angles are of degrees and radians. 360-degree is equivalent to 2 pi radians. 180-degree is equivalent to pi radian. 90-degree is pi upon 2. All right. So this is basically it. Now we are going to discuss steps to solve trigonometric functions with angles in radians. The steps are exactly the same, just the angles are in radians, but still I'm going to make you write them all down. All right, so start writing. And one more thing, if you stick to my notes, it will help you a lot because my notes are extremely comprehensive and I suggest you that you just don't simply watch the video, but go grab a paper and a pen and start writing these notes as I write them on my screen. Because believe me, 1 month before your CIs, these notes are going to help you a lot in revising stuff. So you do want to write them down. So, all right. Steps to solve trigonometric functions. Trigonometric functions with angles with angles in radians. Step number 1, check the range. Step number 2, alter the range if necessary. Alter the range if necessary. Step number 3, find the basic angle in radians. Find the basic angle in radians. Step number 4, apply ASTC and check the quadrants in which answer is lying. And check the quadrants in which answers are lying. Step number 5, apply the following rules. Apply the following rules. The rules are the same as before, but this time I'm just going to give you a visual. All right. If the answer lies in first quadrant, it's going to be theta. If the answer lies in second quadrant, it is going to be pi minus theta. All right. And if the answer lies in the third quadrant, it is going to be pi plus theta. And if the answer lies in the fourth quadrant, it is going to be 2 pi minus theta. 2 pi minus theta. All right. The same visual is also, of course, true for angle in degrees. Only instead of pi, we are going to use angle in degrees. Angles in degrees. All right. And step number 6 is to give the final answer. Give the final answer in radians. In radians within the basic range. Within the basic range. All right. So this was the basic overview of what we studied in AS. If some topic is from these from the ones studied right now is unclear, I would recommend you to go visit AS concepts first before proceeding further. All right. So this is all studied. Okay. So now let's start solving some questions. Let's say we have with us cosec theta is equal to 2, and the range is the basic range, which is 0 degree x 360 degree. This is our range. Now we need to solve it. So now we know that cosec theta is equal to 1 upon sine theta is equal to 2. Sine theta is equal to half. Theta is equal to sine inverse of half. And basic angle is, if you solve this on the calculator, you will get 30 degrees. All right. Now let's apply ASTC. Sine is positive in this quadrant and this quadrant, 30 degree, 30 degree. All right. So the answer would be theta is equal to 30 degree and 180 minus 30, 30 degree and 150 degrees respectively. So this was a very simple question. Let's do a couple more examples. Now let's say we have sec theta is equal to 2. 0, theta, 360 is the range. Now we need to solve it. I think I would use red pen because it's more clear. Yeah, let's just use red pen here. Okay, cot the sec theta is 1 upon cos theta is equal to 2. Cos theta is equal to half. Theta is equal to cos inverse of half. If you solve this on the calculator, you will get the basic angle, which is 60 degrees. Now we'll apply ASTC and check in which quadrants the answer lies. Now we know cos is positive here and here, 60 degree and 60 degree. So the answer would be 60 degree and 360 minus 60, which is 300 degrees. All right. Another question. This time we are going to use radians. cot theta is equal to 1 upon under root 3, 0 theta 2 pi. All right, so let's just start solving it. Cot theta, we know that it is equal to 1 upon tan theta, with 1 upon under root 3. Tan theta is equal to under root 3. Basic angle is equal to 1 upon 3 pi. All right, so let's just apply ASCC. Tan is positive here and here, pi upon 3 and pi upon 3. So theta would be pi upon 3 and pi plus pi upon 3. Theta is pi upon 3 and pi plus pi upon 3 is 4 pi upon 3, which is our answer. All right. Now let's do a couple more questions so that everything is crystal clear and there is no room for error. Cosec square theta is equal to 4 upon 3. The range is 0 theta 360. All right. Now we know cosec square theta is equal to 1 upon sine square theta, which is 4 upon 3. All right. For sine square theta, wait, I'm just going to use red. For sine square theta is equal to 3. Sine square theta is equal to 3 upon 4, and if we remove this, we get under root 3 upon 4, which is sine theta is equal to plus minus. Remember, whenever we remove under root, we always get plus minus, and not just plus. Plus minus under root 3 upon 2, right? So now we're going to apply ASTC. ASTC and check in which quadrants the answer lies. So sine is positive in this and this, and we are also looking at negative values of sine, which are in third quadrant and fourth quadrant. All right. So we are going to find the respective angles. Firstly, let's find the basic angle, which is sine inverse of under root 3 upon 2. Whenever we calculate basic angle, we ignore this sign. We ignore this negative sign. So we will get theta is equal to 60 degrees, which is plus minus. All right, because it lies in both positive quadrants as well as negative quadrants, as indicated by this. Okay, so 60 degrees, 60 degree, 60 degree, 60 degree. All right, so theta is 60 degree and 180 minus 60, which is 120 degrees, and 180 plus 60, which is 240 degree, and 360 minus 60, which is 300 degrees. So this is our answer. I hope you understand. All right. So yeah, let's look at couple more questions. More advanced this time. Cosec theta cosec theta plus 30 is equal to 4. And we have the range theta 360 degree. Now this question, by looking at this, cosec, yeah, cosec theta plus 330. Yeah, by looking at this, we can safely jump to the conclusion that this requires this range to be altered. All right, so we will firstly alter the range. If we alter this range, theta plus 30, we get 30 degrees here, and 360 plus 30, 390 degrees. All right, so we altered the range. Now let's solve this. Cosec theta is equal to 1 upon sine theta plus 30. All right, is equal to 4. Sine theta plus 30 is equal to 4. And the basic angle is sine inverse. Sorry, sine theta plus 30 is going to be 1 upon 4. Yeah, sine inverse 1 upon 4 is our basic angle, which is 14.5 degrees. Now let's apply ASTC and check in which quadrants the answer lies. ASTC, the answer lies in this first and second, since sine is positive in these two quadrants only. 14.5, 14.5. All right. So for theta plus 30, we have 14.5, and we have 165.5. And we'll also include 360 plus 14.5, since the range is greater than 360, the typical range. All right. So theta plus 360, theta plus 30, we have 14.5, 165.5, and 374.5. So the range is between 30 and 390. So we can safely reject this because it is outside the range. All right. So now we are going to find theta and not theta plus 30. So 30 would be subtracted, 165.5 minus 30, and 374.5 minus 30. And theta is 135.5 degrees and 344.5 degrees, which is our answer. Now let's look at another question. Question says sec 2 theta minus 60 is equal to 5, and the range is 0x 360 degrees. All right, so let's start it. Sec theta is 1 upon cos theta, 2 theta minus 60, which is 5. Cos 2 theta minus 60 is equal to 1 upon 5. And the basic angle is theta is equal to cos inverse 1 upon 5. Basic angle is 78.5 degrees. All right. And we also need to alter this range because You can see this. The range needs to be altered. So 2x minus 60. All right. So in order to alter this first, we'll multiply it step by step. So well, first we will multiply it by 2x, 0, and this is 720. Now we're going to subtract 60 from it. 2x minus 60. This gives us minus 60, and this gives us 660. All right. Now let's apply ASTC and check in which quadrant the answer lies. A, S, T, C. So yeah, answer lies cos is positive in this and in this quadrant. All right. So 2 theta minus 60, 2 theta minus 60 or 2x minus 60, which is the same thing, is 78.5. 78.5 to 81.5 degrees. 360 minus 78.5 is 281.5 degrees. Now, since the range is greater than 360, we will keep on adding 360 to these values till it exceeds the range. All right. 78.5 plus 360 gives us 483.5, and 281.5 plus 360 gives us 641.5 degrees. All right. And now if we add 360 again to these values, we'll get an answer which lies outside this range. And we don't want that to happen. All right. So two, now we need to find for theta or x rather, as stated in the question. Yeah, x theta, pretty much the same thing. 2 theta, 78.5 minus 60. We had to add 60 here, and we'll simply get 138.5, 341.5, 498.5, 701.5. Now simply divide it to get 69.25 degrees, 170.75 degrees, 249.25 degrees, 350.75 degrees. So this is our answer. But as you can see, this question also requires a negative range. So we can also make a negative range, but in this particular question, it would be of no use as the basic angle is 78.5, all right, which already exceeds this range. So for question, let's say if the basic angle was not 78.5, but it would have been, let's say 15, which would be negative 15 here. So we would have made uh, a separate diagram similar to this one. All right. So let's just solve another question. And as of the negative range questions, we have already studied it in AS. If I believe there comes such a question, I will be solving it. All right. This is pretty basic. So yeah, cot theta. Another question. Let me pick up a bit harder one. Um, yeah, so that's the hardest it can get at this point without studying any more concepts. But yeah, I'm going to solve another one. Cosec theta minus pi upon 3 is equal to 3, and we have a range of x to pi. All right. Cosec theta is 1 upon sine theta minus pi upon 3 is equal to 3, and sine theta minus pi upon 3 is equal to 1 upon 3. Basic angle is a sine inverse 1 upon 3, which is 0.340 degrees. Now we need to alter the range as well, so let's just alter it. Minus pi upon 3 minus pi upon 3 will be 5 pi upon 3. All right, this is the altered range. Draw ASTC, and check the range in which the answer lies. So that would be sine is positive in this quadrant and second quadrant. So let's just write it here. Theta minus pi upon 3 is equal to 0.34, and pi minus 0.34. So theta is, if we add plus pi upon 3 here, theta is 1.39 degree and 3.85 degree, which is our answer. All right. So whatever we studied till now was pretty much from AS, and I think it clears the concepts, all the ambiguities you had. All right. So next class onwards, we are going to actually start A2 trigonometry. So be prepared, and I hope you would understand it.